Okay, so today we're going to be talking about meiosis and sexual reproduction. Some people call it meiosis, so it's just a different way to pronounce it. You'll hear it both ways. I typically say meiosis, but it goes along with sexual reproduction. So the first thing I want to talk about is what meiosis is. So we know that mitosis is when a cell divides. Meiosis is the same thing. It's when a cell divides, but mitosis is when body cells divide. Meiosis is when sex cells divide. So that was the answer to number 1. Make sure that you go ahead and summarize that in your own words. Number 2 talks about the stages of meiosis. So we'll go ahead and look still at this picture. You can see they have a lot, mitosis and meiosis have a lot of similarities at first, and that is because meiosis's first stage is prophase 1, and then it goes into metaphase, then it goes into anaphase, and then telophase. So the first 4 stages are just like mitosis. The way that meiosis is different, since we are dividing sex cells instead of body cells, we have to do another division. So this next step would be prophase 2, then we would have metaphase 2, then anaphase 2, and then finally telophase 2. So go ahead and answer question number 2. The whole reason that we have 2 divisions is because, again, mitosis is cell division of body cells, where meiosis is division of sex cells. So essentially, if we didn't divide twice, we would end up with too many chromosomes, because with sex cells, you're going to end up with some male cells and female cells together. When they combine, you want them to end up with the same as the parent cell. So for example, if the parent has 46, if it came out and the offspring had 46 and then it combined, so a male offspring of 46 and a female, then we wouldn't have 46 when they combine together to make an offspring. So it would have too many. So that's why they come out with half of the number of the parents. So this is a good demonstration. Mitosis, the parent has 46 chromosomes. The 2 cells at the end have 46 chromosomes. With meiosis, if the parent has 46 chromosomes, you're going to end up with 4 cells at the end instead of 2, and all of those are going to have half of what the parent has, which is 23. Some more differences of mitosis and meiosis. Mitosis, remember, goes along with asexual reproduction, and mitosis is the cell division of body cells. So a few examples you can see below: the pancreas cell, heart cell, blood cell, lung cell, egg cell, and so on. Meiosis goes along with sexual reproduction, and it produces cells like egg cells and sperm cells. So, I know this is a silly topic for some of you. Some of you are uncomfortable talking about this or want to laugh when we're talking about it. But you should probably know that the sperm cells come from males and the egg cells come from females. So, essentially, when the egg and the sperm combine, we're making offspring. So, again, that's why we want each one of these to have 23 chromosomes. So the egg would have 23, the sperm would have 23. And when they combine to make a baby, that baby would end up with a full 46 chromosomes. The next part, going back and just comparing mitosis and meiosis, you can see from this chart, mitosis ends in 2 identical body cells. So if we started up here, this one had 4 chromosomes. At the end, the 2 offspring both have, your 4 chromosomes. With meiosis, we don't want the offspring to be identical to the parent. okay? Again, because that would result in too many chromosomes. We want them to have half of what the parent has. So you can see up here, they started with 4, but down here, each cell ended up with 2 chromosomes. So they're different than the parent. And so also they have half of the number of chromosomes as the parent has. So mitosis ends in 2 cells, meiosis ends in 4 cells. So that is the answer to 6 and 7. Make sure that you're in the right spot with your notes. If you need to pause and go back and answer something, go ahead and do that now. We're going to move on to number 8. So number 8 says, how are mitosis and meiosis alike? So the main ways that they're alike is they both are a way of cell division, and then they both have the same phases. So at first, so mitosis has prophase, metaphase, anaphase, telophase. Meiosis has prophase, metaphase, anaphase, telophase, and then it does it over again. So prophase 2, metaphase 2, anaphase 2, telophase 2. So that's one way that they are alike. How are they different? Number 9, you can see here that they're different because mitosis ends up in 2 cells, so 2 daughter cells. So those 2 cells are identical to their parents. And then over here, you can see meiosis ends up in 4 daughter cells, but all of those cells are not exactly like their parents. They only have half of the chromosomes that their parents have. Whereas over here with mitosis, they have the 2 daughter cells have exactly the same amount as their parent. On number 10, what is a pro for sexual reproduction? So if you look at this list, sexual reproduction has a couple different pros. One good thing is that everything is different. Nothing is identical. So the daughter cells are not identical to their parent. The reason why that's good is because if there was a disease that affected one of the cells, it would not necessarily affect all of the cells because one cell might not be strong enough to fight off the disease, but some of the other cells are different, and so they might be able to fight off the disease. So that also helps the species continue to grow, because going back to the peanut butter example from the last one, if something like peanut butter could wipe out a species, that whole species is gone. Whereas in this case, if a disease wipes out one person or one cell, it doesn't necessarily wipe out all the other ones. One bad thing about sexual reproduction is because it does require a male and a female, it takes more time to find a mate. One person or one organism, I should say, can't do it by itself. So with asexual reproduction, they didn't have to find a mate. They could do it by themselves. So that was a pro for asexual reproduction, is the time factor. Going on to the next one. 2 words that you're going to hear a lot while we're talking about meiosis is the word diploid and then also haploid. So looking here, this is a picture of mitosis. You can see we have the prophase, the metaphase, the anaphase, the telophase. So what diploid means at the end, you can see they use the word diploid, 2 diploid cells. What that means is, I always think of the word double, but basically diploid means that you're ending up with however many chromosomes that you started with. So you're doubling the original cell and you're making 2, okay? So in the very first stage, we had 2 chromosomes. At the end, we had 2 different cells, and they both had 2 apiece. So diploid, I always think of double. And then with haploid, this is meiosis, but it's kind of a summarized version of meiosis. It's not showing all the stages. But you can see here with the parent cell, this parent had 4 chromosomes. And then at the end, we had 4 different daughter cells, but each one of those only had half of what the parent had. So with haploid, I think of half. They have half of the number of chromosomes as their parent. And again, the reason behind that is because we have to mix male and female for sexual reproduction to occur. So we want each one to have half, so when they mix with the other, so let's say these were female. If I mix a female with a male, the male's also going to have 2, so when they combine, they will have 4. Continuing with haploid and diploid. So you can see with the haploid, it says 1 copy of each chromosome. So with haploid, they're getting 1 of each. Whereas with diploid, it says 2 copies of each chromosome. So they're ending up with double. Some more about haploid and diploid. It says haploid cells have 1 set of chromosomes, which usually you'll see represented by the variable N. And then diploid have 2 sets of chromosomes, so 2N. So again, haploid is, I think, of half. Diploid, I think, of double, so that 2 would represent double. So 2 ends, whereas haploid is half, so it's represented by 1 end. And then finally it says you receive a haploid set of chromosomes from each of your parents, making you a diploid organism. So the mom would give you half of her chromosomes, or share half of her chromosomes. The dad would do the same, and then you would end up with a mixture. So you would end up with half of both. Okay, so go ahead and take a second and answer number 11. And 12 is on the screen right now. So 2 haploids combine to make a diploid. Okay, and last thing with haploids and diploids, just another example to help you soak in what that means. Here it shows you a male lion, a female lion. You can see after meiosis, this male lion created 4 daughter cells, and those daughter cells are sperm since he's a male. The female lion created 4 daughter cells, and those daughter cells are eggs since she's a female. And so what happens is after they mate, he gives a sperm, she gives an egg, and when they meet together, that's what's called a zygote. So a zygote is when you have a male sperm and a female egg meet together. Okay? And then essentially that would make your cub. So some more about a zygote, and see here just a picture of a female. A female gives an egg, a male gives a sperm. When those 2 things meet together, they form a zygote. And then eventually that zygote will form an embryo, which is a baby. Okay, so go ahead and take a second. Answer number 13. We're now on number 14. So another word for sex cells is gametes. It says meiosis produces 4 genetically different haploid cells. So male haploid cells, again, are the sperm. Females have the egg. And then one quick thing I wanted to point out here is with meiosis, we said they end up in 4 cells. Well, if all of them are male, then all 4 sperm can be used in sexual reproduction. But with a female, if she produces 4 daughter cells and they're all eggs, or 4 daughter cells, 1 would be an egg, and 3 of the others are just polar bodies. So 1 of the eggs can be used in sexual reproduction. Males can use several sperm in sexual reproduction, but females can only use 1 egg. So it says the 3 polar bodies, so the 3 that are not used are recycled back to the body so they can become eggs later. Go ahead and answer number 15 if you have not already done so. So male haploid cells are sperm and female haploid cells are eggs. Next thing, just going on and talking about gametes for a moment. I'm actually going to end this video and start a part 2. So just make sure that you have questions 1 through 15 answered so far, and then you can go ahead and start video 2.